Okay, now we're going to take a rational function that doesn't automatically does not work and go through the entire process. All right, so you first have to check to see if it's continuous. So positive 5, because that would be the opposite of 5, plus 5 would zero out. So positive 5, but is not in the domain, so we know that that will work, and since that works, it will be differentiable. If it's continuous on that domain, it will be differentiable. And now you have to check to see, is f of a equal to f of b? So plug -4 into the numerator and denominator. Well, in the denominator, the opposite of -4 is positive 4, which is 9. But that part doesn't even matter, because look at, when you plug in -4, so negative, opposite of -4 squared plus 16. Well, -4 squared is 16. -16 plus 16 zeroes out. So this will equal 0, and when you put positive 4 in there, so 0 divide, so one of them's 9 and one of them's 1, but that doesn't even matter, because 0 divided by any number other than 0 is going to be 0. So we know that that applies. Since those three things apply, we can find the derivative and set the derivative equal to 0 and solve for the x. So we checked for continuity and differentiability. We checked if f of a is equal to f of b. And then now we're going to do the derivative. So remember the quotient rule. G times f prime, so -2x, subtract f times g prime all over g squared. And then you're going to do the distributive. You're going to simplify. So -2x times x is positive 2x squared. -2x times 5 is -10x. There's that subtract sign from right here. -1 times -x squared is positive, so we're subtracting all of this stuff. So -1 times -x squared is positive x squared. -1 times 16 is negative, but subtract each of those. Subtract a positive is a negative. Subtract a negative, that becomes a positive, and we can remove the parenthesis bars. All right, and now you can simplify that. 2x squared subtract x squared is just x squared. And then there are no other x's, so you bring down -10x, and you bring down positive 16. And now, so we've done that, we found the derivative. Now we're going to set the derivative equal to 0. So instead of y prime, we put 0. And then if you notice, this is just a polynomial that will factor. What are factors of 10 that add up to, I'm sorry, factors of positive 16, I reversed the process, that add up to -10? Well, -8, -2, they multiply to be 16, they add to be -10. So you put that in factor form, you solve those two x's. But now let's look at our interval. Our interval is between -4 and 4. Well, 8 does not fit in that interval, so x equal to 8, that one will definitely not apply, but 2 will fit in there. So because of that, Rolle's theorem applies, and I'll show you graphically why that's true. So this blue graph right here, this is f of x, and I have it highlighted between just like this right here, between -4 and 4. So I did a kind of a close-up shot. Oh, I wish I would have moved that ahead of time. And then notice right here at 2, if we move up the screen, there is a line. The tangent line to this graph is horizontal. So that slope, the tangent slope, is equal to 0, which is the then criteria. The slope of the tangent line of the function will equal 0. All right, that's it for this one.